I'm Ian Clark, and this is my Interactive Advanced Concepts Presentation 6 for Chemistry 1. And this is the hybrid rocket engine experiment. And in this experiment, we got hydrogen peroxide, active dry yeast, a mason jar with a lid, and then a ZD noodle that I've kind of cut flat on each end so it'll sit better on top of the jar. And then we have just a basic grill lighter. So in this experiment, pasta will be our fuel, and the oxygen that is generated from the decomposition reaction will be our oxidizer. And rockets require an oxidizer and a fuel to generate thrust. So this is a hybrid design for a rocket engine, but we should be able to see some thrust generated as the oxidizer causes the fuel to burn off more quickly. The decomposition of hydrogen peroxide causes water and pure oxygen gas to form from enzymes in the yeast that catalyze the production of oxygen gas. So we'll explain that reaction a little more. Go ahead and test it out and see if it works. And then, so first I'm going to add hydrogen peroxide. I'm just going to add a small amount because this reaction can happen very, very quickly, a very fast rate. It can catalase can cause it to catalyze very quickly and actually blow the yeast foam bubbles out of the top, and it won't allow the noodle to be lit. So we'll pour a little bit of the dry yeast in here, and if we need to add more later, we can. If it doesn't work, so we put the lid on here, and this is the exothermic reaction, so it can generate a little bit of heat. So we're gonna put this on here and light it and see if we get we gotta get the noodle to actually ignite. We may need to add a little more hydrogen peroxide and yeast to this reaction. See if this speeds it up any, gives us a little more. Swirl it up so that you can see it. There it goes. We can see it attempting to generate thrust. And if I can get it a little closer to the camera, you can kind of see it pushing, turning the flame slightly blue as it oxidizes the fuel. I'll attempt it one more time with a little bit more. Hopefully it doesn't blow out the top, which is very possible. Well, now we're getting some of the bubbles coming out of the top of the noodle, so it's likely not going to allow me to. You can see the flame popping there a little bit as the oxygen gas is pushing out of the top. So it didn't work perfectly, but we did get a little bit of oxidization of the fuel. So what happens in this is hydrogen peroxide is an unstable oxygen-oxide single bond, and the peroxide bond consists of atoms in the oxygen ion in the oxygen state of -1. Normally the oxidation number of oxygen in compounds is -2, but in the peroxide bond it's -1. Hydrogen gives up a single electron to oxygen in hydrogen peroxide, and it consists of two hydroxyl groups joined by a covalent oxygen single bond, and oxygen is very electronegative. So the decomposition reaction catalyzes hydrogen peroxide into water and oxygen gas, and we'll look at the the equation, but yeast is not part of the equation because it's only a catalyst and it doesn't come out in the products. But that's the equation. As you can see, the covalent bond of hydrogen peroxide gives up electron to the oxygen gas, and there's a covalent bond between the two water molecules, and the covalent is oxygen requires two electrons to fill its outer shell. So that's the chemical reaction that we see as the yeast catalyzes the hydrogen peroxide, and what's released is pure oxygen gas, is what we see oxidizing the fuel in this reaction, and left behind we have essentially just water and the leftover yeast that's now dead from the reaction with catalase. So that's interactive advanced concept presentation 6.